Section 6.5 will be a fairly quick little section. It's kind of a funny topic that doesn't quite fit anywhere else. It's a topic called complex fractions. And what that title means is fractions inside of fractions. So what that means is, in a situation like this one we have over here on the left, you have a numerator that's x plus 6, but then you have a denominator that's 12x over x minus 2. In other words, what you're looking at here is this divided by this. And our first technique for working out a complex fraction, simplifying it down into simplest form, involves writing it exactly like this. Instead of writing it as a numerator-denominator, in writing it as a division problem of one thing divided by another thing. And the reason why that's a good idea is we know how to divide fractions. To divide fractions, you multiply by the reciprocal. So this x plus 6, which I'm going to write as x plus 6 over 1 just for convenience, is going to get multiplied by x minus 2 over 12x. And then you multiply out your numerators, you multiply out your denominators, see if there's any reducing. In this case, there's no reducing. 12x is not going to cancel with either one of those factors in the numerator. The problem on the right is a slight bit more challenging, but same basic idea. Write it as a division symbol rather than a numerator-denominator fraction. So 6x fourth over x minus 3 divided by 12x over x plus 2, and then turn that division into multiplication. Leave the first fraction alone, flip over the second fraction. Now in this case, we do have some cancellation. You'll notice that if we cross-cancel 6 and 12, we can also cross-cancel one of the x's. Now remember, x to the fourth is x times x times x times x. You're only canceling one of those x's away, so there's still going to be 3 x's left over. But aside from that, there's no other reducing here. We have x to the third times x plus 2 in the numerator, and 2 times x minus 3 in the denominator. This technique, where you write it as a division and you multiply it by the reciprocal, this works pretty good when your denominator is just a single fraction. Unfortunately, that's actually not all that common. Quite often, the denominator that you're going to be taking a look at, it'll have more than one piece to it, like this one here. So there is a second technique, and the second technique is much faster in a situation like this. And what this technique involves doing is you multiply the top and bottom of the fraction by the common denominator of all the little denominators. So in this case, our denominators that I'm talking about the x and the 2x, and they have a really obvious common denominator. The common denominator is 2x. And what you do is multiply the whole big fraction, numerator and denominator, by 2x. Here's why that works. It's a bit of a magic trick until you see what happens here. That 2x is going to get distributed in. It's going to get multiplied by all 4 pieces of what's going on here. It's going to be 1 times 2x. There's going to be minus 2 over x times 2x. We're going to have 5 over 2x times 2x. And we're going to have 2 times 2x. And what this allows you to do is, in these situations here, cancel those little extra denominators out. And what you're left with is a fraction that has no little denominators in it. It has an overall big denominator. 5 plus 4x is the denominator of the whole fraction, but those fractions inside of fractions thing that was going on, that's gone. Of course, you should look to see if this reduces any, and to figure out if it reduces, you're going to have to start by factoring. probably ought to write this part in descending order just out of a good habit to have. But it turns out nothing will cancel there, so that's fully reduced just like that. So let's do one big example of a major complex fraction problem. But aside from one tough example, just to make sure we've got the whole idea, these two techniques are the two things that you need to learn in 6.5. Either multiply by the reciprocal, write it as a division, multiply by the reciprocal, or multiply top and bottom by the LCD. Here's an example, obviously a fairly large, complicated example. I have to choose which technique to use. Well, when I look at the denominator, and I see the denominator has two fractions in it, that's the thing that tells me I should be using the second technique. Things will be a lot faster if I do that. I'm going to multiply top and bottom by whatever the overall common denominator is for all the little fractions. And if you look at x squared y and xy squared and xy and x squared y squared, the overall common denominator for everything is x squared y squared. As you practice this technique, you may get to the point where you're getting pretty good at it. And if you're pretty good at it, you might be able to skip the step that I'm about to write here. What I'm going to write here is the distribution step, where the x squared y squared gets distributed to everything. There's a pretty good chance that as you practice, you'll get to the point where you can visualize what's happening here, and you can imagine the cancellation without having to actually write it on paper. But if you find yourself making mistakes on a regular basis, then probably you should write it on paper until you get better at it. And that's one thing that a lot of students don't quite understand about mathematics. There's nothing wrong with using the paper. Put stuff on the paper so that your brain doesn't have to hold it. That's why paper was invented. It's really good for that kind of thing. And then as you get better and you start to feel more comfortable, maybe you can do more things in your head, but don't force yourself to do that if you're not ready. Okay, so I distribute in the x squared y, and then I do all the little cancellations. Like when these things cancel here, the x squareds cancel, one of the y's cancels, and I'm left with a single y. A similar kind of thing happens here. When I do the cancellation here, I'm left with a single x. Oops, I forgot an exponent down here. There we go. When I do my cancellation here, I'm left with both an x and a y. And when I do my cancellation here, I have nothing. The x squared y squared cancels the x squared y squared. So when I'm all done with this, what I have left in the numerator is 2y plus 3x. Maybe I should scroll up a little more. There we go. And in the denominator, I have 5xy plus 2. Nothing is going to factor, there won't be any reducing, so that's your overall answer there. So, practice both of these techniques because in some situations technique number 1 is better, and in some situations technique number 2 is better.